Okay. So today we'll take up further okay. And last time we finished off till the effects of different speeds of rotation. When we discussed that the Earth spins with the greatest speed near the equator, whereas the speed diminishes when it comes to the poles. So that is why the Earth appears to be bulging at the equator and flattened at the poles. Now we take up the new heading today, having day and night. And as it is spinning, we know that the seasons are also possible. Because if it only revolved and no rotation, then only one side would have faced the entire type of season. But then it is also rotating. That is why we have day and nights and seasons possible. Now let us see. Life would not be possible on Earth if it stops rotating. The phenomena of day and night would disappear. Portion of Earth of the Earth facing the sun would experience continuous sunlight and warmth, while the portion away from the sunlight would experience night and low temperature for eternity. Thus, extremes of temperature would make Earth inhospitable and unsuitable to live. Now, as I told you, had if the spinning stopped, then definitely the days and nights would not be caused. So now the portion which would be facing the sun will have continuous daytime, and the portion just opposite to it, since it is not rotating, then it will have night forever. So definitely the people living in the nighter section will not be able to live for long. That means their work will suffer. So it will be inhospitable and unsuitable to live. Right now we know that after a 24-hour rotation, we will have the change of day and night, beginning from sunrise, then noon, then dusk time, and then gradually night. Please switch off your mic. Then we move on to the next heading called revolution. The annual movement of the Earth around the Sun along a fixed path is called revolution. Now, the circular movement, this is Sun in the center, Earth starting from here, moving till here, coming to this point, and then this, and then back to this point. This is known as a revolution. Now, revolution is the regular process and it is done on a fixed path along which the Earth revolves, and that fixed path is called its orbit. Now, the Earth revolves along its orbit of approximately 965 million kilometers length. My goodness, see the length in millions, 965 million kilometers length at the speed of 29.6 kilometer per second. In a single second, it is covering a distance of nearly 30 kilometers. 30 kilometer एक second में जाता है. Imagine the speed in which it is moving. It takes 365 days, 5 hours, 48 minutes, 46 seconds, approximately 365, half days. Now you need to know these figures. It takes 365 days, 5 hours, 48 minutes, 46 seconds, etc. Now the details maybe in a revised book figures might be a little different. All we need to know is that it takes 365 and a half days to complete one revolution. For the sake of convenience, 365 days is taken as a single year. The extra quarter of a day adds up to make a whole day in the period of 4 years. Thus, we have a year of 366 days every 4 years. It is termed as a leap year, February 29th is the additional day added to compensate the difference of the common year 365 one quarter. The year 2012 is a leap year. Can you say which was the first leap year of the century? When will you again experience a leap year? So now basically here they are telling you that since it takes 365 one quarter days, that means one fourth of a day is taken, and one fourth, one fourth, one fourth, and another one fourth if you add up will make 4 upon 4. So then it needs 4 extra quarters to make it. So every fourth year we have 366 days, which makes it a leap year. Now, in a leap year, the month of February has 29 days, and on other years, it has only 28 days. Now, did you know the distance between the Sun and the Earth is not constant throughout the year? This is because the orbit is shaped like an ellipse, and is not circular. When the Earth is nearest to the Sun at a minimum distance of 147 million kilometers, it is said to be at perihelion. It occurs on 3rd January every year. At aphelion, the Earth is farthest away from the Sun at a distance of 152 million kilometers, and it occurs on 4th July. Now, children, please see this diagram. Now, in this, they have tried to show you the Earth and the position of the Sun. Now, here they have shown you the Sun right in the center. Actually, it is basically the elliptical path is not very accurate. I mean, the path is accurate, but the positioning of the Sun is not in the center all the time. It is slightly towards the right side of the screen, slightly more towards the right side of the screen. Clear? So now they are telling you when the Earth is farthest, so it is at the aphelion, and when it is nearest, it is perihelion. So supposing imagine the Sun at closer to the right hand side, then that closeness is the perihelion, and then the farthest distance is the aphelion. Now this I will be sending you a video will be more clear in that. Effects of Earth rotation. Now, revolution. Now, what will be the effect when the Earth is revolving? The revolution of the Earth, along with its inclined axis, determines the primary distribution of the Sun's energy throughout the Earth. Its primary effect is the occurrence of different seasons throughout the Earth. The varying length of day and night throughout the Earth are a result of this. Now we know that since the Earth is revolving around, so it is causing these seasons. Now before we go into the phenomena of seasons, I have prepared a elaborate explanation for phenomena of seasons. That means this page onwards, from where it is written phenomena of seasons, this page and this page. Instead of reading it, I have prepared a lovely video of it which will make things clear. But before I give you the video and the explanation, I would just like to explain to you. Can you see the screen which I want you to see? Now Sun is in the right hand side, and see the Earth's position in the left. This and this. So our concentration now is on this position. Now, if you see that the Earth's axis is tilted, that means North Pole is slightly towards the Sun. It is closer to the Sun, and South Pole is away from the Sun. Can you see this? Now, it is during this time. Please do not open your mic. This is something very important. Now, in this first position, though it is written second and this is called first, but we begin from here. So, in this position, the northern pole is closer and experiencing sunlight. And if you see, the equator will be little downer towards the other side. So basically, the direct sunlight is falling on the Tropic of Cancer, if you see it. Why? Because the North Pole and South Pole are slightly tilted, 23.5 degrees tilt, you remember? Now, if you see closely, you will find that since North Pole is towards the sun more, that means the northern hemisphere will have summers at this time. So this is called summer solstice, and it is maximum on 21st June, the summer solstice. And if you see the southern section, that is the southern hemisphere, it will be having winters. That means when northern hemisphere has summers, the southern has winters. And in summers, we have longer days in the northern hemisphere. पता है ना गर्मियाँ लंबी गर्मियों में दिन लंबे होते हैं. You must have heard. If noticed, the days are longer. We have sunlight even till 6:30. And now 21st June has crossed. It's July now. So gradually the earth is moving towards and must have reached to this arrow now. Clear? July, then August, and then in September it will be here somewhere. So here, let's talk of this first. So things we notice is in the northern hemisphere, since it is tilted more towards the sun, it is having summers right now. If you see June and all have summer. In June we have we are living in northern hemisphere. India comes in the northern hemisphere, so we have summers. And in the southern hemisphere, that means Australia right now must be having winters. Australia lies in the southern hemisphere. You remember the continent, the island continent is Australia. It is having winters right now. And in northern hemisphere, since we are living in northern hemisphere, we'll talk of more of the northern hemisphere. So northern hemisphere has winters and the southern has northern has summers and southern hemisphere has winters. In the northern hemisphere, days are longer and nights are shorter. In the southern hemisphere, days are shorter, nights are longer. Now, here reaches here, come to this portion. Now, this is called solstice. Clear? Why? Because one of the hemispheres is getting maximum heat. In this case, it is the northern hemisphere which is getting the maximum heat. Now, gradually the Earth has reached this point where it is written 3. Now, this is the time when we have equinox. That means the sun rays are falling equally on both the hemispheres. Equinox. The word equinox tells me something equal. Please switch off the mic. Please switch off the mic, the disobedient child, and do not open the mic. It disturbs the whole class. So now we see that the the position of the Earth is at the equinox, where the sunlight is falling towards the side equally, the northern and the southern hemisphere equally. And so they have days and nights are of equal length. And in the northern hemisphere, it is autumn equinox, and in the southern hemisphere, they have the spring equinox. Clear? In September, we have the autumn. That means the Patjhad ka season. Okay? Then gradually the earth moves, and comes to this position. Now, please see this again. The northern pole is away from the sunlight, and the southern is towards the sunlight. Can you see? Since the earth is slightly tilted, so the northern is away and southern is towards the sunlight. So it is very obvious that now it is this December time when the earth has moved away, the northern portion where we are living, the northern hemisphere. India comes in the northern hemisphere. So we have winters in the northern hemisphere and summers in the southern. That means in December, when we celebrate Christmas time, we celebrate in winters. Can you imagine Australia has some Christmas coming in summer? No snowman, no sledge. Santa Claus is coming maybe in sweaty conditions in Australia. But in the northern hemisphere, December time is the winter time, and the solstice is 22nd December. You see now here again the days would be shorter in the northern hemisphere. जाड़ों में दिन छोटे होते हैं. You remember we have early night approaching us. So in the northern hemisphere we'll have short nights and longer days. Sorry, long nights and shorter days. And in southern hemisphere we'll be having longer days and shorter